So guys, let's all go through this part together then. So just in your workbooks that you're working on, we'll go through from the previous exercise on derivatives of exponentials. We're going to go through question 5 and question 6. And we'll see how we're going. I might address the earlier parts of 7. Exercise 2F, question 5, we'll start with. So we have the function of x is e to the kx plus x. And we're told f dash of 0 equals minus 8. Find k. Alright, so only one variable. This one's not too bad. What we need to do here is find the derivative function. That's our first step. We need the derivative function. So I'm going to differentiate this here. Derivative of e to the kx. Alright, it's e to the f of x. So the derivative will be f dash of x, e to the f of x. That's okay. Start right now. Alright, if you have e to the 3x, it goes 3e to the 3x, plus 1, e to the kx, k e to the kx, and then the derivative of x plus 1. Okay, and then we just use the information we've got. F dash of 0 equals minus 8. So when I put 0 into this equation, it's going to be k e to the k times 0. That's equal to minus 8. Now, k times 0 is just going to be 0. I'll do this in a series of steps. Now, e to the power of 0, any number to the power of 0 is 1. We'll take 1 from both sides, and we have the value of k. Alright, so questions similar to that will pop up in previous tests and the tests coming. Okay, on to question 6 then. It tells you by substituting e to the ln 2 for 2, differentiate 2 to the power of x. Okay, so let's explain what's going on here. This popped up in the exam a couple of years ago. There was a question to differentiate an exponential that wasn't e to the f of x, it was a number to the power of x. So if we have a number to the power of x, like this circumstance, 2 to the power of x, we don't have a rule to differentiate that yet. There's one at the bottom of the page. Y equals 2 to the x. Instead, what we can do is we know e to the power of ln 2 will simplify to 2, right? E to the power of ln 2 will simplify to 2. So that means I can write this function. I can substitute e to the ln 2 where the 2 is. Okay, if e to the ln 2 simplifies to be 2, these are the same function. Okay. Now, one of the questions that kept popping up today is I've said ln 2, if you focus on that part, that's just a number. And so what we have up here then is we have e to the power of kx. E to the kx. Remember, e to the kx. The derivative then is ke to the kx. So in this circumstance, ln 2, e to the ln 2x. All right, I'll explain that again. So we recognise we've got e to the power of some number. This is a number. You put it in your calculator, it's an irrational number. An irrational number times x, e to the power of kx. That's exactly what's going on here. If we have e to the kx, the derivative is ke to the kx. E to the f of x, f dash of x, e to the f of x. So here we have e to the ln 2 times x. All right, e to the kx. The derivative, ke to the kx. That's what's going on there with question 6a. The same with 6b. In 6b, they get you to prove the formula. And I've listed the formula at the bottom of your page. on page 15. If y equals a to the x, there's the formula there. Now, that's something that we'll recap a little bit more as we approach the test. Okay, let's talk really quickly about 7 because we've got time. This is the first part of question 7. And 7 is a good question. It's popped up in 2022 exam, and it has popped up in tests before as well. What we have in question 7 is we have the tangent to x squared e to the minus x. This is the function. The tangent to this function at point P is horizontal. The tangent to this function is horizontal. What that means, horizontal tangent, it means the slope is 0. So what you do here, you find the derivative function, okay, u dash, v dash. I'll do this quickly, you don't have to copy it down, I'll film it, you can have a look at it later. U dash v plus u v dash. All right, find the coordinates of the tangent. Well, the coordinates of the when it's horizontal. Horizontal when the slope equals 0. How might we solve something like that? Factorization, looking along. Sorry, there should be a negative there. U v dash. Looking along, e to the negative x is common, and so is x is common. What would we be left with? 2 plus, that would take. Alright, apply the null factor law. Either this component is 0. Here we'll get x is 2. Over here we'll get x is 0. E to the negative x, an exponential, never equals 0. So we've got 2 answers, 2 places where this curve is horizontal. Now, 4 out of 5 marks, because it says find the coordinates, all right? We've got x values, we need y values. How do I find the y value?
The x value.
Original function, okay? So we put that 0 in there. If I put 0 in here, what's my y value? That's 0, so 0 times anything is 0. And if I put 2 in, I'll have 4e to the minus 2. Alright, so 2, 4e to the minus 2. That's question 7. Really good. So we just steamrolled that before we end the lesson. Alright guys, well done. Excellent work. So just keep hacking away at it, and we'll catch up with you next